Hello and welcome back to the channel. In this video, we're going to be learning about the compareTo method in Java. Now we say that the compareTo method compares two different strings lexicographically. This term might not make too much sense to you now, but by the end of this video, you'll understand what it means. Now before we try to understand why the compareTo method is important or what it does, we're going to first learn about something called ASCII values. In Java, every single character has a corresponding integer. If you look at this, you notice that the character uppercase A has a corresponding integer with a value of 65. In the same way, uppercase B has a corresponding value 66. C has a corresponding value 67. This is going to go on until the character Z, where uppercase Z has a value 90. These integer values are known as ASCII values. Now we know that the lowercase characters and uppercase characters are different. So in Java, lowercase characters also have their own set of ASCII values. But if characters work perfectly fine, then why do we need these ASCII values? Now you must already know that computers process information using binary, where everything consists of zeros and ones. Characters cannot be directly converted to binary. So instead what we do is we associate a corresponding integer to a character and we convert that integer to binary so that we can represent a particular character in binary. This is important in executing a program as well. Even characters like spaces have a corresponding ASCII value. Now you don't have to memorize the ASCII values for every one of these characters. It's only important to know the ASCII values for alphabets. Over here, the uppercase alphabet ranges from ASCII value 65 to ASCII value 90, and lowercase characters small a to small z ranges from 97 to 122. ASCII values also help in implicit type conversion. If you've seen a video on type conversion, you'll know that variables of the car data type can be implicitly converted to an int data type. Over here, I made a variable called ch of the car data type and I set it to the character lowercase a. I'm going to make an integer variable int b and I'm going to set this to ch. You notice that we don't get any error because this ch or this character a has been implicitly converted to an integer. So we know that integers include numbers. How can I convert a character to a number? What Java does is that it just converts this character into its corresponding ASCII value and stores our character in a integer. So if I had a println statement and I print this int variable b, we should get 97 because we remember from our table that the corresponding ASCII value for lowercase a is 97. When I run this program, we do indeed get 97. Now we're going to change this lowercase a to an uppercase a and see what we get. If you remember from the table I've shown before, the corresponding ASCII value for uppercase a is 65. So this character uppercase a is going to be converted implicitly to 65 and is going to be stored in this variable b. When I print it, it's going to print this number 65. And you notice that when I run the program, we do indeed get 65. Now that we understood what ASCII values are, we'll try to understand what the compareTo method actually does and how it works. Now the compareTo method has the same syntax as any other Java method. As the name states, it's just going to compare two different string objects. So over here, we're going to have our first string object and then we're going to use the dot operator to call the compareTo method, and in the brackets, we're going to add our second string object as the parameter for the compareTo method. The compareTo method basically checks if this string, obj1, is greater than or lesser than this string, obj2. But what exactly do we mean by greater than or lesser than? All it's checking is that if we arrange these strings in an alphabetical order, like you would in a dictionary, is this string going to appear after this other string or before this other string? If it appears after this other string, we'll say that it's greater than this other string, obj2. But if it appears before this other string, we say that it's lesser than obj2. The compareTo method basically works like a dictionary. Now if our first string object appears after this second string object, it means that our first string object is greater than our second string object. If that's the case, our compareTo method is going to return a positive number. However, if our first string object was lesser than our second string object, it means that this appears before this other string is going to return a negative number. If the two strings are equal on the other hand, that is, they're both located in the same position in a dictionary, it's going to return 0. Now we'll try to use the method with some simple strings and see what kind of outputs we actually get. So over here, I have a simple Java statement. I'm basically saying ball, which is one string, dot compareTo this other string zebra. In other words, I'm checking if this string ball appears before the string zebra or after the string zebra. If it appears before the string zebra, it means that it's going to return a negative number. Our string ball is lesser than the string zebra. If it appears after the string zebra, it means it's going to return a positive number. It's greater than the string zebra. In this case, they're definitely not equal strings, so it's not going to return 0. Now, before we run this program, we'll try to predict what kind of output we're going to get. Are we going to get a positive integer, 0, or a negative integer? If you look at a dictionary, you'll notice that the word ball definitely appears before the word zebra. So we should get a negative number. When I run this program, you notice that that is actually what we get. We get a negative number. In fact, we get a specific negative number. We get negative 24. Now we'll just reverse these two strings. So now my compareTo method is checking if this string zebra appears before the string ball or after the string ball. Before, we noticed that the string ball appears before the string zebra because we got a negative number. This must mean that the string zebra appears after the string ball. This statement should return a positive number. When I run this program, you notice that we do get a positive number. We get the same number where the sign is reversed. Now it's a positive number. Now we'll just change this string. We'll change zebra to something like cat. When I run this program again, you notice that we do get a positive number. And it makes sense why. If you check a dictionary, you'll notice that the word cat definitely appears after the word ball. But why do we get this specific positive number? Now, to understand the exact output of a compareTo method, we need to understand how the compareTo method actually compares two different strings. So over here, I took two strings, tomato and apple, and I'm basically checking tomato.compareTo with the string apple. In other words, I'm checking if the string tomato exists after the string apple or before the string apple. To compare these two strings, the compareTo method is going to take the starting character of both the strings. This is actually what we do in a dictionary as well. We're going to look at the alphabetical order of the starting characters or the starting alphabets to decide which string appears first. So Java is going to do the same thing. Now I told you that the compareTo method is quite similar to just a dictionary. So over here it's going to take the starting character of tomato, which is T, and the starting character of apple, which is A. Then it's going to take the ASCII values of these characters. The ASCII value of T is 116 and the ASCII value of A is 97. When I'm saying tomato.compareTo apple, it's going to subtract these ASCII values. It's just going to say 116 minus 97. This is going to give us the output 19. And our output also makes sense. We get 19 because that's the difference between the ASCII values of our starting character, and we get a positive 19 because the string tomato exists after the string apple. The number that the compareTo method tells us by what extent this first string tomato exists after the second string apple. Now we're going to implement that same statement in our program. Over here you notice that I wrote the same statement, tomato.compareTo apple, and the integer that is returning is going to be printed by this println statement. When I run this program, you notice that we do get 19. Our string tomato is ahead by 19. Now we'll change the order. What if I say apple.compareTo tomato? Now it's checking if this string apple appears before the string tomato or after the string tomato. We know that this string apple definitely appears before the string tomato. So this should return a negative number. Now what negative number is it going to return? It's just going to be negative 19, because you notice that the ASCII value of the starting character of apple is 97 and the ASCII value of the starting character of tomato is 116. 97 minus 116 is just negative 19. When I run this program, we do get negative 19. So the order is pretty important. But what if I take two strings that look like this? Over here I have the string argon and I have the string apple. Now to find the output of the compareTo method, Java is going to do the same thing. It's going to take the starting characters of both the strings. Over here, the starting character of argon is lowercase a. The starting character of apple is also lowercase a. The ASCII values are equal for both the characters. So if we just subtract 97 from 97, it's going to return 0. But 0 means that both the strings are the same, and in this case, they're definitely not the same. So what Java is going to do is that it's going to move to the second character. The second character for argon is R. The second character for apple is P. As usual, it's going to take the ASCII values of the characters. The ASCII value of the lowercase r is 114 and the ASCII value of lowercase p is 112. If I say apple.compareTo argon, it's going to subtract the ASCII value of the character r from the ASCII value of the character p. So in this case, it's going to be 112 minus 114. So the output for this statement is going to be -2. So in my program, I changed my strings to apple and argon. In this case, it's checking if apple appears before or after argon. When I run this program, we notice that we do get -2. Apple appears before argon by this extent 2. It's kind of like saying the string apple appears 2 spots before the string argon. Now I just made a small change in the two strings. Over here, I changed the first character of my string argon to uppercase A, and my string apple is still the same. Now Java is just going to take the starting characters uppercase A and lowercase a. For us, uppercase A is the same as lowercase a. Both of them are the alphabet A, but Java is case sensitive. This is why uppercase A has an ASCII value of 65, but lowercase a has an ASCII value of 97. So in Java, these two characters are going to be considered different characters. So if I say argon.compareTo apple, it's going to subtract the ASCII value of our lowercase a from the ASCII value of our uppercase a. 65 minus 97 is going to be -32. So I wrote the two strings over here as well, and when I run this program, you notice that we do get -32. Now in a dictionary, uppercase or lowercase doesn't really matter. This is why I said that the compareTo method is similar to a dictionary. It's not a dictionary. Since Java is case sensitive, uppercase characters are different from lowercase characters. Over here, if I change this to apple but keep the first character uppercase, even though they are the same string, the compareTo method is still going to return -32 because the uppercase A has a different ASCII value from lowercase a. Now there is a way to overcome this particular problem, but I'm going to talk about it later in the video. Now we're going to look at another unique example. Over here I have two different strings. One string is the string app and the other one is the string apple. Now we're going to try to evaluate how the compareTo method is going to compare these two different strings. Now the first thing it's going to do is obviously take the first character. In this case, the first characters are equal. They have the same ASCII values. Then it's going to move on to the second character of both the strings. The second characters of both the strings are also equal because they have the same ASCII values. Then it's going to move on to the third character of both the strings. The third characters of both the strings again have the same ASCII values. Now Java notices that there is no string to move on to. The first string has ended. The second string still has two more characters left. When I say app.compareTo apple, it definitely can't return 112 minus 112. It can't return 0 because 0 must mean that the two strings are equal. The string app is definitely not equal to the string apple. When this is the case, what the compareTo method does is that it finds the difference in the length of the two strings. It's going to say app.length minus apple.length. The string app has a length of 3. It has 3 characters. The string apple has a length of 5. It has 5 characters. 3 minus 5 is -2. So this statement app.compareTo apple is going to return -2. Again, the order is extremely important. If I change this to apple.compareTo app, now it's going to return +2 because 5 minus 3 is 2. To demonstrate this, I took two similar but different strings. Here, I'm comparing this string race with this string race car. As usual, the method is going to check every single character. It's going to start with this character R, but the first and the second string have the same starting character. It's going to move to the second character A, but it's the same case again. They have the same character because they have the same ASCII value. It's going to move to the third character and it notices the same thing again. And finally, the fourth character also is the same for both the strings. Since this string ends over here, it's going to instead find the difference in lengths. The length of the first string is 4. The length of the second string is 7. And 4 minus 7 is just -3. So this println statement should print -3. When I run this program, you notice that we do get -3. Unique cases like these are extremely important in finding the output for a compareTo method. Now, before I mentioned a common problem with the compareTo method. Over here, if I take the string apple, where the starting character is lowercase, and if I take the string apple again, but the starting character is uppercase, the strings are obviously equal. But the compareTo method is going to return the number 32 because the ASCII value of lowercase a 97 minus the ASCII value of uppercase a 65 is 32. The program is doing exactly what it's supposed to do. Java knows that if two characters have different ASCII values, they are different characters. But because of the way we've defined our ASCII values, we come across this common problem where we can't really compare two words accurately just if one of the strings is uppercase and if the other string is lowercase. To fix this issue, we can use a different compareTo method called the compareTo ignore case method. It's a different method, but it does the exact same thing. Over here, all I need to do is add ignore case. This is going to call the compareTo ignore case method, and this is going to compare two different strings without checking if one of the characters is uppercase or lowercase. Over here, this should return the value 0. And when I run this program, you notice that we do get 0. The way this method works is that it's going to convert both the strings to uppercase or lowercase, so that both the strings have either uppercase or lowercase, and we don't get any issues like these. Even though the compareTo method is often considered a little confusing, it just works like a dictionary. But instead of comparing two different alphabets, it compares the ASCII values of characters. We're only just changing the terms we're using. I hope this video was helpful. Thank you for watching and have a great day.